Okay, our next speaker is going to be William Lowell Putnam. Bill is a trustee of the Lowell Observatory here in Flagstaff. He's written numerous climber guidebooks of the Rocky Mountains of Canada and interior ranges of British Columbia, and of course the famous book for those of us that know a little bit about Slipher, The Explorers of Mars Hill, published in 1994, which I am glad to say I finally got a copy of last night and in the bookstore, and Percival Lowell's Big Red Car, published in 2004. So, Bill, it's your turn, Bill.
All right, kids, wake up. It is fitting that this conference meet in Flagstaff. Behave yourself. Well, Mars Hill was the place where one of the greatest unsung scientists of the 20th century did his thing, to the undying glory of Lowell Observatory. I speak of an Indiana farm boy who was asked by his employer to look into the composition of a spiral nebula in search for data on the possible means of formation of the solar system, and in so doing hit upon the most fundamental fact of modern astronomy, the concept of an expanding universe. His findings soon began to open the eyes of scientists worldwide to the true size and glory of the universe, of which, despite man's proclivity to self-importance, planet Earth, with all its egos, is but an infinitely minute part. While our prejudices are understandably in favor of one of our own, that is Vesto Melvin Slipher, we take some comfort once again from the 2003 joint publication of Helge Krag and our distinguished friend and historian of science, Robert W. Smith. It was entitled, "Who Discovered the Expanding Universe?" In this summary, prepared for Science History Publications Limited, we read with pleasure the lines, "It is more sensible to start our history either in 1912 with Vesto Slipher, first discovery of a large spectral shift for a spiral nebula, or with Einstein's cosmological field equations." Farther down, we read a quotation from the Czech-born professor emeritus Martin Hurwitz. The Dutch astronomer Willem de Sitter, noting that Einstein's general relativity equations could also describe an expanding universe, had suggested that such an expansion took place as early as 1917, citing Slipher's earliest results in support of his contention. This tribute should have been delivered some years ago, perhaps while its subject was still alive to appreciate it. In fact, however, it was started some dozen years after V M's death by a professional historian, Bill Hoyt, then in the employ of Lowell Observatory. But he too went and died. It really should have been written before 1980, so that a proper public memorial could have been named after him, such as the world's biggest telescope in space. And it would have been written soon after then, had I been on the ball. However, I wasn't. Back in 1983, I was a television broadcaster whose principal station was at Springfield, Massachusetts, in that state's 2nd Congressional District, then represented in the Congress by the late Edward Patrick Boland, the ranking majority member on the House Appropriations Committee and chairman of its subcommittee dealing with science and education. The adjacent Congressional District number 1 was represented by Silvio Otto Conte, the ranking minority member on appropriations. Much to my surprise and amusement, our television station, an affiliate of NBC, began to receiving visits and telephone calls from professional astronomers around the United States. High-level delegation arrived at the studio offices of WWLP from Princeton and MIT, but naively I failed to understand the real purpose of these unusual guests, for none of them ever said it straight out. So they were all politely told, but the person you should be talking to is my little brother. He's chairman of classics at Brown and the trustee of Lowell Observatory. Go thou to Providence. The visiting delegates, however, were undeterred by these persistent demurrals and insisted that it was the television broadcaster they wanted to educate. Finally, I picked up a long-distance phone call from Dr. George Wallerstein, an old mountaineering pen pal and chairman of astronomy at the University of Washington. Is this mic working right?
A little louder.
There you go. Come on, stay up here. Who do you have to know? How's that? That better? Yeah. Okay, thank you, dear. I'll keep trying. So I says to George, what in hell are all these high-class astronomers after me for? With their talk about the telescope in space. I keep telling him to go bother my little brother in Providence. But next week there's another batch of big shots coming here after me. What's this all about? George was patient. He'd done a good bit of exploratory and recreational alpinism in the Monashi Range of British Columbia, an area that was part of my volunteer responsibility for the climbers' guidebooks. And he was used to being hectored for information. The problem is not scientific, Bill, it's political. For several years, the astronomical community has been urging the Congress to appropriate funding for a telescope in space. But we always run up against your congressman, Mr. Boland, who doesn't think it will work and refuses to allow an appropriation. The whole science wants to get him to change his mind, and your influence is our last hope. I like George. He's always a good bear in the mountains and a respected scientist too. So I agreed to have a private chat with my congressman on the topic of astronomy in space. Unfortunately, it never occurred to me that there might be a naming opportunity with Mr. Boland, or perhaps Mr. Conte could doubtless influence as well. So the space telescope was soon funded and named, not from many people's ideas of the greatest astronomical researcher of modern time, but from the man who ballyhooed those findings more effectively. Mea culpa, mea culpa. I have spent the last 30 years trying to rectify that nearly unforgivable oversight. In an even earlier incarnation, in 1950, I was the third man in the two-man department of geology at Tufts University, and one day found myself faced with a co-ed's question about the possibility of life existing someplace else in the universe. So I told the lady, come back in a week or so, I may have an answer. So I inquired quickly by email of V M Slipher, then nearing retirement here at Lowell Observatory, and soon received the following cryptic response. Imagine 100 billion rose bushes and only one blossom. While the overall content of these remarks is my personal responsibility, countless phrases within this statement are more properly credited to many others at Lowell Observatory. I see them scattered around the room here, who provide ongoing help and the continuing astronomical education of a one-time geologist, now a retired broadcaster. VM, as we still call him here in Flagstaff, is best known for his published discovery in 1913 of the extraordinary radial velocities of spiral nebulae as revealed by the enormous redshifts in the absorption and emission lines in their spectra. This discovery was a necessary prerequisite to follow Lemaitre's Big Bang hypothesis of 1927, and several years later, Edwin Hubble, using the work of Henrietta Leavitt, and to announce his discovery of the direct relationship between the radial velocities of nebula and their distances that has enabled modern astronomers to gauge the approximate age and dimension of the known universe. In the course of this facet of his work, Slipher also discovered that the spiral nebula are rotating, carried out innovative studies of the relative motion and distribution of nebula and globular star clusters, and found that certain more properly called nebulae are shining only by the reflected light from nearby stars. This discovery, importantly, first demonstrated the existence of dust in interstellar space. 3 years earlier, VM had shown the presence of vast clouds of interstellar gas within the Milky Way. In addition, VM's spectrographic observation of the nebula resulted serendipitously in the discovery of a permanent aurora. This in turn led him to undertake a long and exhaustive study of the light of the night sky. Aurora and the zodiacal light, which produced a series of discoveries bearing on the nature and composition of Earth's upper atmosphere. Slipher's carefully conducted researches also contributed significantly to planetary astronomy. In 1903, he was the first to show spectrographically that the rotation period of Venus must be far longer than the 23 plus hours that astronomers had assumed it to be for more than 200 years. And in 1911, he was the first to make a spectrographic determination of the rotation period of Uranus. From 1901 to 1903, he made early spectrographic measurements of the rotation periods of Mars, Jupiter, and Saturn. Between 1904 and 1907, Slipher obtained a series of spectrograms of the giant outer planets, which revealed for the first time strange bands in the near infrared range of their spectra that became progressively stronger with distance from the sun. 25 years later, these bands were shown to be caused by methane and ammonia in the atmospheres of these planets, and Slipher helped confirm and extend this finding with the help from Lowell Observatory's then junior astronomer Arthur Adell. In 1908, VM claimed the detection of small amounts of water vapor and oxygen in the atmosphere of Mars. And in 1905 and 07, and again in 1924, he attempted to detect the presence of chlorophyll on that planet with negative results that have not been challenged by subsequent observations made on Mars itself. Not the least of his contribution to planetary astronomy was his overall planning and supervision of the search for my great-uncle's postulated X, which led early in 1930 to the photographic confirmation of the planet Pluto by Clyde William Tombaugh here at Lowell Observatory. Slipher also concerned himself with extensive observations of comets over the years and with spectrographic observations of the solar corona. For this latter work, he led 2 Lowell Observatory expeditions to observe solar eclipses, to Syracuse, Kansas in 1918, and to Ensenada, Mexico in 1923. He did not formally publish all his work, preferring on occasion to communicate his results privately to his employer or to other astronomers through correspondence. Thus, some of his later radial velocity determinations of nebula and globular star clusters first appeared in papers published by others. And thus only a few astronomers knew that Early in 1913, Slipher had concluded that the spectrum of the Crab Nebula, more recently one of the most interesting and astronomically productive objects in the heavens, was the most peculiar ever known. V M was born on a farm in Mulberry, near Frankfort, Indiana, on 11th of November, 1875. The second of the 9 children of David Clark and Hannah Abbott Slipher, your grandma. 4 of V M's brothers, Claude, Edward, Elmer, and Jay, stayed home in Indiana as farmers. One, John, became a professor of agronomy at Ohio State University, and one, Markwood, became a local businessman. A younger brother, Earl Carl, the 5th son, born in Mulberry on the 25th of March, 1883, became a staff astronomer at Lowell Observatory in 1905. Prior to various Mars missions by NASA, EC had become known as one of the world's leading authorities on the planet Mars and on planetary photography in general. EC, as he was generally called in Flagstaff, served his adopted community as a state representative, mayor, and state senator. Based largely on EC's archival photographic inventory, Lowell Observatory was the, we called it reluctant, recipient of a federal research grant from the U.S. Weather Bureau. They don't come like reluctants anymore. That was to study planetary circulation as seen from the outside. Both brothers spent their entire working careers at the Lowell Observatory and both served as director. The Sliphers were descended from a German, that's Pennsylvania Dutch stock, that had been resident in Eastern America since the 17th century, and members of which, along with every other immigrant group, gradually migrated westward. Almost certainly, life on the family farm helped VM to develop the strong, robust physical constitution that stood him in good stead for the more strenuous aspects of observational astronomy in later years. Astronomer Henry Gickless, who joined the Lowell staff in 1931 and worked with VM for 23 years, remembered that Slipher in his 60s could climb effortlessly on the steep slopes of the 12,661-foot San Francisco peaks, where the observatory maintained a mountain station in the late 1920s and early 30s. Gickless once told me, V M Slipher, 35 years my senior, was always ahead of us boys climbing the mountain. We puffing and panting, he disgusted, waiting for us to catch up. Slipher graduated from high school in Frankfurt and taught at the country school north of that community briefly before entering at age 21 the Indiana University in Bloomington on September 20th, 1897. On June 19th, 1901, he received an A.B. degree in mechanics and astronomy. He was granted an A.M. degree on June 24th, 1903, and his doctorate on June 23rd, 1909, also by Indiana. His academic honors included election to the honor societies of Phi Beta Kappa and Sigma Chi. His subsequent career in observational astronomy brought him 4 honorary degrees, including an LLD from Indiana in 1930 and science doctorate degrees from the University of Arizona, Tucson, and Northern Arizona University here in Flagstaff in 1957. He also won high honors from his colleagues in astronomy, receiving the Lalande Prize of the French Academy of Science in 1919 and the Henry Draper Medal of the National Academy of Sciences in 1932. the Gold Medal of the Royal Astronomical Society, and the Bruce Medal of the Astronomical Society of the Pacific. Slipher's professors at Indiana included Dr. John Anthony Miller, who in 1906 became director of Sproul Observatory at Swarthmore College in Pennsylvania, and Wilbur Edelman Cogswell. Slipher apparently never recorded when or how he became interested in astronomy, but certainly Miller and Cogswell played major roles in his choice of the field. Both men remained among Slipher's closest friends throughout their long lives. It was Cogswell who urged a reluctant Percival Lowell to bring Slipher to Flagstaff and to Lowell Observatory in 1901. My philanthropic great uncle replied, "I shall be happy to have him come when he is ready. I have decided, however, I shall not want another permanent assistant, and take him only because I promised to do so, and for the term suggested. What it was escapes my memory." Slipher's term turned out to be 53 years. He was an assistant here at Lowell until 1915, when he was made assistant director under Uncle Percy. After Lowell's death on November 12, 1916, he became acting director and was named director in 1926, serving in that capacity until his retirement in 1954 at the age of 79. In his later years, he lived quietly in Flagstaff, occasionally taking an interest in the observatory and astronomical affairs, but carrying out no further research. He died on November 8, 1969, 3 days before his 94th birthday. On January 1st, 1904, Slipher married Emma Munger in Frankfort and brought her to Flagstaff, where they established a home on the observatory premises up here in Mars Hill. They had 2 children, Marcia Francis, Mrs. K.J. Nicholson, and David Clark Slipher II. During his years in Flagstaff, Slipher was active in community and business affairs as well as in astronomy, particularly in the decade following Lowell's death. He became a member and served as chairman of the Flagstaff School Board and was instrumental in establishing the first high school in this city. He was also a participant in the founding of the Northern Arizona Society of Science and Art and Flagstaff's Museum of Northern Arizona. As a businessman, Slipher acquired extensive property in and around Flagstaff, operating a retail furniture store for a time, managed many rental properties, and was a founder of a community hotel in Monte Vista, of which he served as board chairman for many years. He became perforce an expert in buying properties that were foreclosed for non-payment of taxes and turning them into paying investments. His daughter and her husband operated one such property, the DA Ranch, south of Sedona, and another was what became the Flagstaff Country Club, for which VM gave the land. VM Slipher's farm background, however, incidentally, served him well in his early years as an assistant at Lowell Observatory, where he was often in charge of the observatory's cow, Venus, and her annual offspring, and was responsible for Lowell's vegetable garden when the observatory's founder and his live-in maintenance man, Ramon Vialma, were both absent. Despite his initial misgivings about his new hire, Uncle Percy soon came to admire and trust his new employee. So much so that in his will, drawn up on 21 February 1913, he specifically named VM to be his successor as director of the observatory. Slipher's first assignment after his arrival on the 10th of August 1901, however, was to master the operation and usage of a spectrograph, his employer had recently acquired from John Alfred Brashear, America's foremost maker of such scientific instruments. Lowell's primary interest in acquiring this expensive instrument was to determine with greatest possible accuracy the rotational period of Earth's cloud-covered but nearest neighbor, Venus. In this search, Lowell was delving into an issue which was then even more controversial in scientific circles than his well-publicized views on the canality of Mars. But controversy and skepticism on the part of other astronomers had little impact on my outspoken and thick-skinned great article. As a resident of the territory of Arizona, Slipher was in a scientific backwater at Flagstaff. There were no other comparable scientists within many hundreds of miles. So he was forced to tame his unique instrument largely on his own, supplemented by such help as he could get from Brashear, much of which was by tedious correspondence. Slipher wanted to go to San Jose to see how the more experienced personnel on Mount Hamilton were handling their spectrograph. But his employer, whose relationship with the lit director William Wallace Campbell was notoriously hostile, would hear of no such visit, telling the younger man he could go there only when he could give them as much as you take. But by mid-1902, Slipher had begun to produce useful spectrograms, so much so that his employer used a sampling of them in a paper he delivered at the 1902 meeting of the American Association for the Advancement of Science. Slipher's personal research interest concerned the determination of radial velocities. That's the velocity of a star or other body along the line of sight of an observer, and with the discovery of spectrographic binary stars by measuring Doppler shifts of the Fraunhofer lines in their spectra, resulting from the differential motion of their components in the line of sight. Lowell encouraged this interest, though he set a firm policy that the planetary work of his observatory must have first priority. Slipher faithfully adhered to this policy and pursued his own work only when time and circumstances permitted. It is notable, however, that his first formal publication was a paper in 1902 in the Astronomical Journal on the variable velocity of Zeta Herculis. Well, you know, I'm glad to see you all here for this conference. It's a grand gesture towards clearing up my long ago oversight.
I once read somewhere or heard somewhere that when Slipher wanted a clear night, he was influential here in Flagstaff and had the lights switched off. Is that just a good story, or is there some truth to it?
Well, there's a sort of truth to it. In that this community has valued Lowell Observatory, valued us very highly. And some years ago, both the city of Flagstaff and the county of Coconino enacted comparable ordinances restricting the use of outdoor lighting at night. And those ordinances are still in effect and still sometimes the subject of a certain amount of grumpiness on the part of businessmen who would rather gain an advantage in light over their neighbors. That's understandable. But we monitor that condition. We keep an eye on it because it's the law of local land. And we are aided and abetted in great measure by the U.S. Naval Observatory, which has a station out here that's very important for use of satellite navigation devices. And the Naval Observatory has the power to condemn things. We can speak softly, but they carry the big stick. Anything else? Yes, sir.
Can I ask how you got into broadcasting?
It was an accident. It was a way out of geology, I guess. I spent 30 very pleasant years building UHF stations, which you probably never heard of as such. But my wife and I ran 3 stations at the time we sold out. Springfield, and in Dayton, and in Salt Lake. 2 of them were NBC affiliates, and I was on the NBC affiliates advisory board, and did secretary-treasurer for several years. So I was a bit of a big shot in the industry. And she was the first lady elected to the board of directors of the National Association of Broadcasters. So we still think of ourselves as broadcasters, even though I've got a better job now. Doesn't pay as well, but it's a lot better job. Anything else? Can I go now?